Well, this is going to be our 8B. We're going to talk about the sun and moon's actual effect on it. We've talked about what a tide is. Now we'll talk about how it changes through a monthly cycle. First off, let's talk about tide producing forces. Sun actually produces 40% of the tide. That's this lighter blue, and it's less than half the moon's, which is 60%, which is this even lighter blue. Adding this whole thing together, this is, remember, this is a spring tide, which we learned from Hewitt Druitt. When we have a full moon or a new moon, we don't normally get a solar eclipse where the moon blocks the sun. I'll actually show you that, I think, in C, but it could be later in this one too. But anyway, 60% and 40%. Sun is much farther away, 40 times farther away, but it's also 40 times bigger. So in our sky, it actually produces about the same apparent size. So the moon can move over the sun to cause a solar eclipse. Our shadow actually tends to be bigger, so the lunar eclipse lasts longer, but it actually will cause an eclipse, but it only happens about twice a year and doesn't happen every time the moon goes around. We have a monthly cycle. Um, Actually, we have what are called spring tides. Spring tides are new moon and full moon. They're caused when the Earth and Moon actually align. So we either have the sun is here, so we have a new moon on this side, or half of a lunar month later, about 2 weeks, we have a full moon on the other side. So the alignment actually works in the same direction, where we get 40% because of the sun and 60% because of the sun, or because of the moon, sorry. And we call those spring tides. That's this blue line, where the high tides tend to be the highest and the low tides tend to be the lowest. So there is that tide. Then we have what's called a neap tide. Neap tide actually happens at either first or quarter, and this is where the moon is actually perpendicular to the sun. It's actually called a quadrature. So we actually have it pulling 60% away from the sun earth line and 40% pulled on that. So look at our high tides are not near as high as they were over here, and our low tides aren't near as low as they were over here. And then we have a halfway position where it actually is in between. This is the highest high tide, this is the lowest high tide, and every tide in between as it's going back towards, this would be a third quarter, as it's moving back towards the new moon, the tides will get higher high tide and lower low tide. So Earth, Moon, Sun, quadrature, 90 degrees. We have the lowest high tide and the highest low tides. So here is the spring tide, 60% because of the moon, 40% because of the sun, darker blue, lighter blue, bigger tide, high tide, smaller, low tide. And then we have it when it's 90 degrees as the new moon moves around for first quarter, 60% pulling this way. We still have 40% for the sun. And then remember, we have that centripetal force where the gravity is less over here. Earth is still spinning in a counterclockwise direction, and that tends to throw the water out. So we do get a tide opposite the body. So opposite the sun, opposite the moon, or opposite the sun and moon. Spring tide, neap tide. Here's an animation that runs through it, and you can see it goes from spring tide to neap tide. It goes from lined up, not lined up, lined up, not lined up. And then basically the moons that are in between cause the tides to go higher and lower. And here are the tides. We actually call it an ebb tide when the water's moving out to low tide, and we call it a flood current or a flood tide when it's actually moving up to high tide. The whole thing is called a tidal range. And you'll be doing a lab looking at the three different types of tidal types that are on this planet, as well as very high tidal range versus a very low tidal range for the most common type of tide. This is a month's tide cycle, and you can see new moon looks like this, full moon looks like that. There's another new moon, there's another full moon, there's another new moon. Halfway in between, the high tides are not quite as high, and the low tides are not quite as low. When we get a full moon, they're higher and lower. These are the tidal cycles. And then if you actually take a look between the highest high tide, the new moon, to the highest tide, the full moon, you can see that the tides get lower and lower and lower and lower until we actually get to the quarter, and then it gets higher and higher and higher until we get to the next alignment, and then lower and higher and lower and higher. And you notice that we have a difference between them. This actually has to do with what's called perigee, where the moon is actually closest to. And then we have apogee, some other place on here, but basically the tides are higher when the moon's actually closer, and then it's not as high when it's farther away. Okay, so this was a month cycle, and there is our bear signifying the end of 8B. Thank you.